Today, I would like to introduce to you the power of the Unix command line with this particular demo. I'm going to use my Mac OS, which is a Unix variant, and you can also use Linux, which is a different Unix variant, but it's installed in the ECF computers. On Windows, you can use MSys2 as your terminal. It's going to be very similar to what I'm going to show you today. Let's get started by opening the terminal. Now let's try to make it full screen here. Now the terminal is going to run something called a Unix shell. So I'm already in that shell right now. On macOS, the default shell is going to be ZSH. On Unix, on other kind of Unix variants, for example Linux, the default shell can very well be the BASH, which is another popular shell, a born again shell. My shell right here is going to be ZSH. The shells are not that different. For the demos I'm going to show today, they're pretty much the same. So at the command line shell, I'm going to try to enter some commands. For example, I can try to enter a command date. That's going to get me today's date. I can also use some of the commands that are built in. For example, echo is a built-in command. It's a very simple command. Whatever you type as a command line parameter, it will just echo that command line parameter. But there's a very interesting use of this particular built-in command. We can echo something called an environment variable. One of the most important environment variables would be the path. The path contains a collection of these absolute paths. These are directories that are kind of all the way down from the root directory, and the path environment variable contains several of these separated by this column. The path environment variable is used by the shell to find the command that you're entering. If we're entering command, as long as it's not a built-in command, for example date, it will try to look for this particular command in each one of these paths until it finds the command in that path. Or if the command is not to be found in any of these paths in the environment variable, it will report command not found. So if I actually try to say which directory is containing this date, then I have another built-in command called which date. And that is built into the shell, and it shows which path contains the date. It will show something called an absolute path, because this path is starting all the way from the root directory, which is the / to contain this particular file. All right, so now let's try to talk about the relative path. We can actually use the relative path to go anywhere we wish on the command line to anywhere in the file system by using the cd command. CD stands for change directory, and it will go to anywhere we wish using the relative path. Of course, we can also use the absolute path, but it's more likely we're going to use the relative path. For example, I can say playground and APS 105. That is a relative path because this is relative to my current directory. Now, if I just directly type cd, it will go to my home directory. So where is that home directory? I'm going to try to use something called print working directory, or PWDE, to print the absolute path of my current working directory. And I can, of course, use the absolute path to go to anywhere. For example, I can say cd to the root directory. I can try to show the files in that root directory by using another command in the Unix command line called the ls. It will show all of the files in the root directory. I can say cd without any parameters, and it will go to the home directory. So pwd, that's going to be the home directory. I can do APS 105, that's going to be my working directory right now, and I go back to the home directory. Either I can say cd, or I can say the cd tilted, and tilted means it's the home directory. I'm going to go back to the home directory. And of course, CD is very powerful. I can use other ways of navigating. For example, I can say cd dot dot. It actually goes to the parent directory because dot dot is representing the parent directory. And now I go back to the parent directory and say dot dot again, I go to the root directory. Now this is actually very useful. By using a combination of cd and pwd, I can easily, and ls obviously, I can easily navigate through my entire file system, and I can easily go anywhere I wish, and it's much easier than using, for example, the Finder or the Windows Explorer. In fact, I have one more trick that I would like to show you. If I go back to the home directory, and now I want to go back to the previous directory that I was in before I typed this particular command, the last command, then I can just say cd minus or the cd dash. Now it goes back to the previous directory. So there are lots of interesting tricks with the cd command. Now I would like to show you one more special directory called the dot directory. So you can say cd dot playground APS 105. It means go to the playground inside the current directory. cd dot dot representing the current directory, and then APS 105 inside the directory called playground. So dot represents the current directory, and dot dot represents the parent directory. So now in this working directory, in fact, this is actually my actual working directory. I'm going to work on all of the files related to APS 105, including labs, midterms, finals, and everything. So I can actually use the ls command to list all of the files that I have right here. But I don't have to directly use ls. I can have quite a few command line options to make the features of this ls even more powerful. For example, I can say ls-l, and that means I'm going to list all of the files and directories in the current directory, but in the long form. So in the long form, you can see I have this one is a file, this is the file name, and I have another name of the directory, obviously. But I also have more information. For example, I have the date and the time, which is the last modified date for the file or the directory. I have the size of the file. I can have also the owner of the file. In this case, it's owned by this account called BLI, which is my personal account on this particular Unix system. And I have staff, which is the name of the group that this particular file or directory belongs to. And then I have something very interesting. I have these characters right here. The very first character, if it's a D, it means that this is a directory. If it's not the D, that means that it is a standard file. So if it's just a dash, it means it's a standard file. Now, we have 9 more characters right here. The first 3, RWX, represents the access permissions for the user or for the owner of that particular directory or file. In this case, the owner is myself, BLI, and this particular directory is readable, writable, and executable. For files, executable means that we can run that file. It's a native executable, probably. For directories, executable here, X means that you can enter that directory. So if it's not executable, then you cannot even enter that directory, let alone doing anything else inside the directory. So in this particular case, this is readable, writable, executable for myself, for the owner, and readable for the group, not writable for the group, and executable for the group. In the directory, it means you can enter the directory. Now, the final 3 characters are WX. These are for the world, for anybody else inside the same system. Can they read? In this case, they can read. Can they write? And can they enter the directory or execute the file? So these are kind of permissions related to this file, and that's sometimes very useful when you actually have multiple users using the same system. For example, our ECF computers obviously had both the faculty members, the professors, the staff, and also the students accessing the same computer. So that's why you need to properly set these permissions so that you don't allow unauthorized access to some of the directories that you have. So now let's explore some of the other command line options. For example, ls-al, that shows not only the directories, the normal regular directories and files, but also showing the directories and files that are hidden. These are the dot files and dot directories that are hidden. And that includes the dot, which is the current directory, and dot dot, which is the parent directory. So A means show all of the files. And we can say ls-ltr, and that is a further combination of even more options, and that shows everything in long form, ordered by their time, and in the reverse timestamp order. So that means that the most recent files or directories will be shown last in this listing. So that's going to be very powerful if you actually know how to use these command line options. And to learn about more of these command line options, you can use a Unix command called man. Man means manual. Look for the general manual for this particular command, man ls. So this is the general commands manual for this ls, and you can go through this particular menu and look at all of these possible command line options, and you can feel free to play around with them. And whenever you're done, you can just press Q to quit that manual. And of course, ls is just to list the current content of the directory. Now let's try to create some content. So one of the most important commands is to create a new directory, and that's called make directory, mkdir. And let's say I want to make a midterm directory. This mkdir, and along with a lot of other Unix commands, you will have to supply the name of the directory or the name of the file. And if you want to do something like mkdir final exam or something like that, it's not going to work very well. Even though there are no errors reported, if you actually try to look at it, you can see that you have two directories created, final and examination, rather than one directory called final examination. So how do we actually create one directory that is called final examination? Well, we're going to have to do either one of these tricks. Either you say final examination enclosed in either single quotes or double quotes. That's going to try to create this new directory called final examination. Or you say final \space examination. That means that you're going to try to escape this particular space using \, and that's going to be fine as well. In this case, of course, the file already exists, so we're no longer able to create a new directory here. How about removing a particular directory? I can say rmdir to remove a particular directory. For example, final that we have created by mistake that I can remove. Make sure that you know that rmdir can only remove a directory when that directory is completely empty. If it contains any files or directories, including hidden files, you are not able to remove that directory. This is a safety measure so that you don't remove a directory accidentally if there's something inside. And let's say I want to remove the directory final examination, and that is fine as well. So now let's try to go back to our midterm folder, midterm directory, and let's try to create a file. So create a file, typically I use a command line editor. So command line editor is very useful because you don't always have to go to Visual Studio Code or anything like that to edit a simple file. For example, my favorite command line editor is VI or VIM, and VIM stands for VI improved, and this is a fantastic command line editor that most people use to say edit a file at the command line. Let's say midterm.txt, and that will be my plain text file for the midterm. So for example, question number 1, question number 2, and so on. And VI or VIM is a very complex editor. It does have a steep learning curve. It takes a few months to get used to it. But once you got used to it, this is extremely handy because it's a very powerful command line editor. And that's why this is something that is a favorite for a lot of the programmers and system administrators. So VI is a highly recommended command line editor. Sometimes you're remotely logged into a different Unix system, like a Linux virtual machine in the cloud, so you're no longer able to use anything beyond the command line editor, such as the Visual Studio Code. But for my local computer, of course, I can use Visual Studio Code to do it. I can say code midterm.txt, and that creates this Visual Studio Code session with midterm.txt included, and that I can do use Visual Studio Code to edit this particular file. And that's a much more powerful editor, much easier to use kind of editor. But one more trick, before you are able to use this code as a command line utility, you have to install it. So you have to say Shift Command P and then type shell to see a particular option called shell command install code command in path. And once you have it installed, now you can actually use the code as a command line to access Visual Studio Code. So now we have the file created. So how do we actually display the content of the file? We can use the cat command, and that displays the content of the file. And that is very handy whenever you just want to show what the file contains. So you don't have to say vi midterm and then get out of it. You can just directly say midterm.txt and you have the content of the file. Now, I can actually try to create a file in a different way. I can use a special Unix command called touch. And touch is able to create a file, let's say finalexam.txt, without using an editor. And if you actually try to do ls-l, you will see that it is a file with 0 bytes. You can just create a file that is completely empty. You can cat that file. It doesn't show anything. It's completely empty. And so that file is created, but it doesn't have anything. In fact, you can use the touch command to change the modification time. And you can, if you're interested, you can say man touch. You can actually adjust the time it takes. So right here, it adjusts the time it's last modified for that particular file. So that's fine. Now, let's try to do something to remove this file. So the rm command removes the file, final.txt. So that is removed. And it's, very fast, very simple. But you don't really have to use the entire full name of the file. You can say rm, or that works with most of the other Unix commands, midterm.star. So star is a wildcard character that represents any number of characters and any character for each one of these. And that is in case that you have a lot of files that starts with midterm dot and you want to remove them all. And that's fine as well. Of course, you will have to be very careful because this rm command doesn't do anything like dragging to the trash can or recycler bin or anything like that. It will just directly remove anything you wish to remove permanently. There's no way that you can recover these files after they're removed unless you have a backup of these files. rm actually has another option that is very powerful. Let's show that option to you by creating a new directory. Let's say midterm2, and inside midterm2, let's create another file, and let's try to make another directory inside midterm2. Let's call it midterm3, and inside midterm3, let's touch another file. And now you can see that we're pretty deep into midterm. We have quite a few directories inside this midterm. What if I want to remove them all? Now, if I actually go back to the parent directory, I can actually try to remove them all by saying rm-r midterm2. And that includes all of the files inside midterm2 and all of the directories and all of the files in those directories and so on. So this is a recursive removal of everything. And now if you do something like that, nothing is remaining. Well, everything will be removed, and that is very handy. Again, this is permanent, so you have to be very careful. If you need a backup, do that before you do that removal. It's not going to be dragging anything to the trash or the recycle bin. And this actually shows the power of Unix. In Unix, just like what we have shown you before, all of these commands, if there's nothing shown as the result, it's successful. So no news is good news. That is the design philosophy of Unix operating systems, including Mac OS and Linux. And at the command line, this is something that is really handy, because if you know what you're doing, this is going to be very, very fast, way faster than using the graphical user interface. So now let's try to create another file. Let's try to do some copying. I would like to copy midterm.txt to midterm2.txt, and that is very natural. It will make a copy of the file, both of these 0 bytes, because I'm using touch to create that file. But we do have a copy of the file. And of course, I don't have to copy the file into the same folder, same directory. I can copy the file to a different directory, and I can name it however I wish. And then I can ls-l ... and I have the midterm.txt right there. And of course, I can move files. I don't have to use the copy. I can say move the file. Let's say what's going on here. Inside this particular directory, I have 2 files, midterm.txt, midterm2.txt. Now I would like to move midterm.txt to ... midterm3.txt. So now if I see nothing's here, and if I go to the parent directory, I see midterm3.txt right here. So now I can actually move it back. I like move midterm star.txt into the midterm. So now I can actually go to the midterm, and I can see everything's moved right here. Moving doesn't have to be moving to a different folder. I can use mv, the move command, to change the name of the file. For example, I can say midterm2.txt to midterm something a little bit more informative, w22.txt, midterm mv midterm3.txt to midterm w21.txt. So this is fine as well. And I just renamed these files. So copying files and moving files to different directories, or just renaming files using the move command, all of these are super easy to do at the command line. You can imagine if you want to do this inside the Finder or the Windows Explorer, it's going to be probably a little bit slower. But if we really wanted to open the Finder or the Windows Explorer for something that we want to do over there, it's going to be fairly easy as well. All you need to do on Mac OS is to use open. Open dot. It opens all of the files inside the Finder. Inside Windows, you have explorer.exe dot, and that will open the current folder inside the Windows Explorer. So that's pretty handy. And you can also open a particular text file. For example, you can say midterm.txt, and that will open it using whatever text editor that you have by default for this particular text file. So now let's try to talk about a few more commands. One more pretty advanced command in Unix is called df. And df is to look at the current file system and see how much space is taken and how much space is remaining, and what are the amount of space that you have in total. So df, that contains the current directory. Well, I have a SSD drive with, roughly speaking, 1 terabyte of storage space, and I used just 14%. So that's pretty simple. And du, this is much easier than, for example, the disk utility in Mac OS. And du is even more useful because sometimes we wanted to find out how much space is used by a particular directory. So I can say how much space is used by the current directory? Well, 0. 0 is used by the current directory. What about the parent directory? Well, here I have a few more directories, and each one of these is going to take some space, and they're going to list all of these and their subdirectories and the subdirectories of their subdirectories, and that will show us the entire picture of how much space is used for each one of these directories. So as you can see, there are a lot of these Unix commands that are super useful, and a lot of these you cannot do very easily using the graphical user interface. So this is it. This is all I would like to talk about related to the basic command line utilities in Unix variants such as Linux and Mac OS, and to a certain extent Windows as well. Oh, by the way, I will have to introduce you the same commands to remotely log into the ECF server. SSH is the command that we talked about in lab number 0's handout. To log in, I can use -l bli and remote.ecf.utoronto.ca, and that remotely logged in to the remote server on the ECF machines. I can also use SSH BLI at remote.ecf.utoronto.ca, and that's going to be exactly the same. Now, at the remote computer, I can do the same thing. It's a Unix system, it's a Linux system, so I can say ls-ls-l. All of that would be equally useful on the remote computer. Now, I could also try to copy a file. For example, let's say I have a file called readme.md here. I would like to copy this file to the remote computer, and I can use the scp command, and I would like to copy readme.md, and I'd like to copy this to the remote.ecf.utoronto.ca. And if you directly do this, it will not do the job. It will try to copy to a file called bli at remote.ecf.utoronto.ca, and that's not what we wanted to do. Instead, we need to try to add a column. So once you add a column, it will copy to the remote directory and to the home directory of the remote server. So you can do another check by remotely logged in to the ECF machines. By the way, I'm not entering passwords because I already have the private public key pair set up. This is a more advanced way of logging into the remote machines without a password. So now let's take a look at the actual files. Yep, readme.md is right here. So that's all I would like to talk about today. Have a nice weekend, and I'm going to probably talk more about the Unix command line utilities in next week's plenary lecture. Thank you.